Hi, I'm an old guy and I do maths. Let's have a look at this problem. What does the graph of this function look like? Now this function is 1 over x to the power of 4. Now this question was put to me by a student, and there's a very simple method for figuring out what something like this looks like. You don't need to have any great knowledge of the graphs of functions. What you need to be able to do is to think clearly and apply some fairly simple arithmetic. Now what we're going to do in order to get an answer for this is we're going to concentrate on the value of x. Now what we know is that if we raise x to the power of 4 without the imposition of this 1 here, if we just raise x to the power of 4 and we make x equal 0, then the function of x is going to equal 0. Now, what does that tell us in terms of this? Well, if we make x equal 0 here, x to the power of 4 will equal 0, and we'll get 1 over x, which means that we have something called an asymptote. This is a value which presumably, and we've yet to prove this, but presumably this function approaches but never reaches. 1 over 0, try it on your calculator, see what happens. I can guarantee your calculator won't like it. So let's draw ourselves a very crude Cartesian plane, and we're just going to put some values into this. That's all we're going to do to figure out what the graph of this thing looks like. We already know that at 0 this thing has no real value. So let's try 1. Okay, so we'll call that 1, and we will raise x to the power of 4. So 1 to the power of 4 is 1. 1 over 1 is 1. So let's mark that there. And we'll also call that 1. This is going to get away on us very quickly, and it's going to be wildly out of scale, but just indulge me. If we make this negative 1, then what we're going to get is we're going to get 1 over 1, because negative 1 to the power of 4 is 1. The negative value of x is negated, so to speak, by the fact that we multiply it out 4 times. So just to be really clear, we're not doing that. What we're doing is that. Now that would give us negative 1, because it would be 1 to the power of 4. We do the indices first, and then it's negative. But here, I beg your pardon, that should be 1. Here, that is negative 1 times negative 1 times negative 1 times negative 1. Did I get all 4 in there? I hope so. And that gives us 1. So this thing's beginning to look as though possibly it might be symmetrical with an asymptote here. Okay, let's try another number, 2. 2 to the power of 4 is 2, 4, 8, 16. This is 1 over 16. So again, this is out of scale, but I'm going to put that dot there. And we'll try it with negative 2. Now everything I said about negative 1 holds for negative 2, so it is going to be 1 over 16. Okay, we'll do it for one more number along here, 3. 3 to the power of 4 is 3 3s are 9, times 3 is 27, times 3 is 81. This is going to be 1 over 81 for the reasons mentioned here. So 1 over 81, so that's negative 3. So we see that we have the beginnings. It's very hard to do this sometimes, and it's I think, even more awkward when you're left-handed. I'm not sure. Anyway, so what we can see is that there is a trend here tending towards the x-axis. Now, no matter what size number we put in here, positive or negative, we're always going to get a result larger than 0. You can put several millions in here, and your denominator can be, a string of zeros 100 long, if you like. But 1 over that will be greater than 0. So we can also say that the x-axis will be an asymptote. And we'll just extrapolate along here and pretend that that never touches the x-axis. Now, what about in here? So let's try this to the power of a half, 0.5. And you can see that I'm going to run out of room here, but as I say, bear with me. So negative 0.5 as well. Well, what is 1 over 2 to the power of 4? Well, the rules about indices and fractions tell you that it's 1 to the power of 4 over 2 to the power of 4. So that is 1 over 16. But what we have is a function that means that this 1 over 16 is going to be the denominator. So just down here, I'll show you what that means. So we have 1 over 16. Well, so that is 1 divided by 1/16, which is the same as 1 times 16 over 1. So at 0.5, this thing has a value of 16 on the y-axis. The function of x is 16 at 0.5. And so this thing does this, and it will do the same thing over here. Now, those of you with a sharp eye will not be surprised by this, because this thing's starting to look like a truncus, 1 over x squared. And surprise, surprise, that is indeed what it looks like. The point of the exercise here, though, is to show you how, without any prior knowledge, but just by using a little bit of reasoning and applying some simple numbers to a function like this, you can work out what its graph looks like. And this is the graph of 1 over x to the power of 4. I hope you found that interesting and useful. If you did, please like and subscribe, and I will see you next time. Bye.